Mercury is the closest planet to the Sun, which on the face of it seems inanimate and completely uninteresting. However, despite its enormous temperature, there's water at its poles. Moreover, the surface of Mercury surprises all astronomical scientists. There are the rarest types of impact craters and even forms of relief unknown to modern science. Finally, although Mercury is very small, it has enough of a magnetosphere to protect its surface from supernova and even a minor atmosphere that should have been weathered by now. Today, we'll tell you about the mysterious Mercury, as well as the secrets of the surface of this small planet. Mercury has a radius of 1,516 miles and is on average only 36 million miles from the Sun, or about 2.5 times closer than Earth. Therefore, 1 year on the planet takes 88 days. The planet's temperature reaches 800 degrees Fahrenheit, but because of its very thin atmosphere, it can drop to negative 290 degrees Fahrenheit at night. By the way, Mercury rotates very slowly around its axis. 1 day on Earth would be 59 days on Mercury. That is, the day and night on the planet lasts for 3 months. What causes such a slow rotation? Mercury is not blocked by the tides of the Sun, as has been assumed for a very long time. It is in spin-orbit resonance with the star in a 3:2 ratio. It rotates around its axis 3 times in 2 revolutions around the Sun. It's thought that Mercury may have previously been in 1:1 resonance, but something, probably collision with a giant object, caused the spin rate to change, as hinted by its many craters, including the impact basin of Caloris. On the other hand, according to research, a group of scientists led by Benoit Noëls have concluded that Mercury may have been in such resonance almost from the beginning of its formation. Another important factor influencing the rotation and temperature of Mercury is its eccentric orbit. The planet's orbit is elongated and resembles an egg, so depending on its position, Mercury's distance from the Sun can range from 29 million miles to 43 million miles. Mercury's orbit has another peculiarity that was discovered only recently. The orbit holds a dusty ring of the planet. Scientists believe that Mercury was too small and close to the Sun to have a ring. Moreover, scientists were going to investigate the planet's orbit to find an area around the Sun that had no dust, but found a dust ring instead. The ring is very thin and 9 million miles wide. The source of the ring could be meteoroids and the dust cluster in the same orbit as Mercury. A group of scientists led by Dr. Peter Pokorny believes that such a phenomenon may not be unique, but common in other exoplanet systems, where different space objects constantly crash into planets without a significant atmosphere. Interestingly, despite its small size, Mercury has a magnetic field. Although its magnetic field is the smallest in the entire solar system and has only 1% of the strength of Earth, it's still capable of reflecting stellar winds off the surface, forming a magnetosphere. Nevertheless, the magnetosphere is probably leaky, that is, it has holes through which sunlight can penetrate. As it flew past Mercury, the Messenger Space Telescope noticed magnetic tornadoes on the surface, beams of magnetic fields connected to the interplanetary space filled with rarefied gas and magnetic fields carried by the solar wind. These openings in the planet's magnetosphere allow us to replenish the barely detectable atmosphere. But we know that the magnetic field is formed by the movement of electric current in the liquid metal in the planet's core. Does Mercury have a core large enough to generate a magnetic field? In fact, Mercury's core is even 1/3 of the planet's total mass. The core has a radius of as much as 1,289 miles, which is only half the size of Earth's. With the enormous size of Mercury's core, University of Maryland geology professor William McDonough explains the initial formation processes of the Sun. When the newborn Sun was surrounded by a protoplanetary disk, most of the formed metal stayed closer to it. Since metal is heavy, it's difficult to eject it far away with gas. So, the large concentration of metal near the Sun during the early stages of planetary birth could have built up Mercury's core to such a large size. However, there are still likely reasons for the high proportion of metal compared to silicates in Mercury. Scientists speculate that Mercury probably could have been much larger than it is now. However, several hypothetical cataclysms could have prevented its mass buildup. One such cataclysm could have been the influence of the forming of Earth and Venus. Both planets could have formed closer to the Sun, then migrated to their current orbits and taken the building material that was destined for Mercury. On the other hand, Mercury's composition could be the result of an impact on the two planets or the impact of a huge space object, causing it to lose about a third of its mantle. A collision with such massive bodies could have thrown Mercury, which was further from the Sun, into its current unfavorable orbit. Impacts from other space objects, the consequences in the form of craters which we see in the images, could have continued to remove the silicate surface of the planet. Nevertheless, all these assumptions are only hypothetical, so we should expect further studies of new spacecraft, such as the Bepi-Colombo mission of the European Space Agency and the Japan Aerospace Exploration Agency, which will focus on the origin of Earth group planets. Still, as much as we would like to learn more about Mercury, it is in fact quite difficult to study up close. From ground-based telescopes, it is extremely difficult to track it at night at the best time to observe it because of its proximity to the Sun, so it also rises only with a star. The Sun's light can damage optics if you observe Mercury for a long time during the day. Moreover, the small planet is harder to reach even than the farthest planets in the solar system because of the star's gravitational pull and temperature. Therefore, a spacecraft sent to explore Mercury must reach the planet very carefully, which is long and risky and is almost always within acceptable temperature limits for operation. That's why only two missions, Mariner 10 and Messenger, were sent to Mercury. Without them, we would hardly know everything we know about Mercury today. Mariner 10 was the first mission to use the gravitational pull of another planet, Venus, to reach a planet. For its maneuvers, the spacecraft used the pressure of solar radiation on its two solar panels. Using its abundant instrumentation, Mariner 10 was able to confirm a moon-like crater-covered surface as well as detect the magnetosphere and rarefied atmosphere of Mercury. Moreover, it was Mariner 10 that discovered the planet's large core, in addition to measuring its temperature on both sides. The spacecraft was able to take more than 2,700 images of Mercury, allowing scientists to create a map of nearly half of the planet's surface from those images. In all, the last Mariner made 3 passes over the inner planet 6 months apart. It did not orbit Mercury, but it still managed to make a breakthrough in the study of the planet. The ship's mission lasted about a year. After orbiting the Sun in late March 1975, Mariner 10 stopped transmitting radio signals to Earth. It may still be orbiting the Sun. The Mariner spacecraft Messenger continued its work 30 years later, in 2004. Unlike its predecessor, Messenger not only flew over Mercury but was also the first spacecraft to orbit the planet, which yielded more in-depth and interesting data. The main goals of Messenger were to collect information on the chemical composition of the planet and its exosphere, to study the magnetic field and its sources, and to study geological activity in Mercury's past and the state of its core at the moment. Before entering Mercury's orbit, Messenger made 3 orbits around it, slowing the craft down. From the start of the flight as of 2014, The vehicle was able to take 200,000 photos of Mercury. It managed to take a total of 2,500 pictures. In early 2015, Messenger began to run out of fuel. At the end of April 2015, Messenger finally stalled and crashed into Mercury, forming a new crater on its surface. All in all, the Messenger mission lasted about 10 years. During this period of time, it managed to make many interesting and unexpected discoveries. The most outstanding can be considered a complete map of Mercury. Messenger captured all the craters and basins that were on the planet's surface, so scientists were able to study its geology in depth. Moreover, the spacecraft was able to determine the chemical composition of Mercury. Thus, its surface contains 46% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium. The ship also indicated to scientists that the planet contains a large amount of sulfur with much less iron. This, as well as direct photos of gentle volcanoes, suggested that Mercury may have previously been volcanically active and even completely covered by a magmatic ocean. When the planet cools after such geologic activity, heavy elements like iron sink downward, which explains the small amount at the top. The magma ocean phase filled the atmosphere with volatile substances including sulfur, sodium, and chlorine, which evaporate only when exposed to high temperatures. As scientists suggested, the magma also melted the planet's interior and probably the upper, but this was not enough to significantly reduce Mercury's mass. Now the planet is no longer active. In addition, as the planet cooled, it began to shrink, forming cracks and ridges along its surface. In addition to traces of lava eruptions, Messenger also found water deposits at Mercury's poles. Water exists there in the form of ice. Despite the high surface temperature, the poles of the planet are not heated by the direct rays of the sun, so the water there always remains frozen. Moreover, it suggests that there may be liquid water inside Mercury under the ice deposit, although this cannot yet be confirmed. Messenger also made an unexpected discovery concerning the planet's magnetic field. It turns out it shifted along its axis by 20% of Mercury's radius. Such an anomaly could affect the planet's surface. For example, solar particles would have greater intensity in the south, weathering elements from the surface. Finally, Messenger took a 2011 photo from the planet's orbit of the entire solar system except for dim Uranus and Neptune. The previous image was taken back in 1990 by the Voyager 1 spacecraft. Still, the most interesting discovery of both spaceships was the surface of Mercury. So let's take a closer look. Mercury's surface has an interesting topography. Although it's almost entirely covered in craters, it also has almost completely smooth areas as well as ridges and troughs. It's difficult to name the exact number of craters, but at this point we know for sure about 567 of the planet's craters, which are also named after prominent people. Most of them are impact craters, that is, damage caused by an impact with a small cosmic body. Such craters are divided into simple and complex by morphology, such as geological differences like peaks, terraces, several rings. On the surface of Mercury, simple craters predominate, especially in the south. They typically reach sizes of 0.6 to 9 miles or depths of less than 7 miles, or complex craters are slightly less common. They are larger than simple ones, ranging from 10 to 168 miles long and more than 7 miles deep. However, Mercury has the most such topographic lesions than any other object in the solar system. Thus, on the surface of the planet, there are 110 craters with a peak in the middle, when, for example, on the Moon, there's only 17 such craters. Besides, on average, small impact craters, there's another type of these craters as impact basins. They can be as large as 200 miles, or even as large as 963 miles. Their rather large numbers on the surface can be explained by the increasing velocity of bodies in solar orbit and a negligible atmosphere. Some of the most famous basins are the Caloris and Rembrandt basins. Caloris is Mercury's largest crater, measuring 963 miles in diameter. In the full image, scientists find that it was previously filled with lava, so you can now see the smooth plains at the bottom of the crater. It is suggested that the object that crashed into the planet and formed Caloris may have also created the chaotic terrain of Mercury, an area mottled with furrows and plains. Further, Rembrandt, the second largest crater, is about half the size of Caloris. It was also probably covered by lava in earlier stages, which is why the area around it is smooth. In addition to these basins, Mercury has several other interesting craters. For example, the Basin Thick is the oldest crater on Mercury. It may be over 4 billion years old. It also has the darkest place on the entire planet, covered in particles ejected by a volcano. There are also special rare types of craters on Mercury. These include elliptical, polygonal, and ghost craters. All of these types have different mechanisms of formation. For example, an elliptical crater is formed because of the low velocity and large volume of the space body. Such craters are about 2 to 4% of the entire surface. The largest elliptical crater is Svendsdatter, 137 miles long. Polygonal, that is, craters with several angles, probably arise because of the structure of the planetary crust and its dilapidation. There's about 33 of these on Mercury. Craters, ghosts, are barely visible because their bottoms are filled with lava deposits, but they are distinguished by ridges along the edges, which have arisen from the rapid accumulation of lava flows. The last interesting type of crater, which can also be clearly seen on the Moon, is a ray crater. Their main feature is the long rays diverging from the crater and having a huge length. For example, the longest lines on Mercury have the crater Hokusai at 2,800 miles. These marks appear because the impact triggers the ejection of subsurface elements that fade over time. So the brighter the line, the younger the crater. Thanks to all these craters, scientists can study the dynamics of the planet's geological activity and, among other things, its age. Thus, young craters are convex, with terraces on the walls, while older craters are very shallow because they're probably filled with volcanic material. Still, for example, while studying crater types and sizes, NASA researcher Caleb Fassett noticed that Mercury was missing craters from 12 to 80 miles. He suggested this may be due to the frequent formation of intercrater plains early in the planet's history. High-surface structures like ridges and escarpments are not too numerous on Mercury, only about 100. All the uplands were formed in different periods and under the influence of different mechanisms. For example, smooth ledges were formed during volcanic activity, and ridges and wrinkles were formed during the cooling and compression of the planet. On average, they all reach a height of 0.07 to 0.5 miles. Some high mountain ranges, which incidentally do not exist on Earth, on Mercury can reach up to 360 kilometers in length, like Antagnati Dorsum. Nevertheless, despite the study of Mercury's surface, the history of global compression is still unknown. Another 27% of the planet's entire surface is occupied by almost perfectly smooth plains with few craters. Such plains are found at all latitudes as well as around large basins. 2/3 of them are formed due to volcanic activity, and the rest is probably due to volcanic particle emissions by the Caloris Basin. The last geological oddity of Mercury, which is not observed anywhere else, is hollows. They were noticed by Mariner 10, but Messenger made clearer images, so it is awarded the first discovery. They're shallow depressions without edges and with flat bottoms that occupy about 0.08% of the planet. In most cases, they are inside impact craters. Scientists speculate that they are much younger than Mercury and are formed by the loss of volatiles from the surface. The process of hollow formation has not stopped, so the surface of the planet may change over time. So scientists believe that 99% of Mercury's surface could be completely transformed in 25 million years. Mercury is a very valuable planet to study the dynamics of surface changes, as well as the mechanisms of the formation of different landforms. Therefore, in 2018, a new spacecraft was sent to observe the first planet of the solar system, which will continue the mission of the previous two, Bepi-Colombo. It consists of two separate spacecraft that will observe Mercury from far and near at the same time. Its primary mission? To answer the questions that Messenger has raised. That is, Bepi-Colombo will investigate in more detail the origin and causes of magnetic field displacement, water deposits at the poles, cavities, and the mechanisms of their formation. In 2025, Bepi-Colombo should enter Mercury's orbit and begin its main work. Hopefully, this new study will be able to solve most of the mysteries of this planet, which will have good implications for our understanding of the history of the solar system.